Good afternoon to one and all. Today we will see the order to see the or observe the deterioration of the building. So when we are doing a visual inspection, so there is a procedure and process is there to see the building. So where are all the locations which we have to give the major focus and the order of visit to the building. So it has been seven different observed orders are there. We'll see it one by one. The first main thing we have to see a wet and water stagnating areas. So mainly the RCC element where it is located externally, the slab, okay, and the exposed walls which are frequently exposed to alternate wetting and drying process. So mainly in the terrace, okay, so it has a direct okay contact to the slab. If the covering skidding provided onto the slab is not properly maintained, there the water will try to stagnate, okay, and then it will try to enter to the pores, okay, in the concrete. So as per the record, okay, and as per the literature survey, it is observed that if a water is standing, okay, in an concrete surface for more than 5 minutes, okay, so it will try to enter into the concrete, and then since if the cover concrete is not adequate enough, it will reach the reinforcement and thereby it initiates the corrosion. And also know about the brick can absorb water. So in the terms, okay, if the water is stagnating, it will be absorbed by the parapet walls or in the from the foundation. Okay, if the tie beam plinth beam is not protected with the DPC, it will try to raise up. The dampness will raise in the brickwork. Automatically, it will cause dampness in the building. So these things first we have to see. And second one, thin exposed non-structural RCC elements. So mainly the sunshades and the kajas and the fins. Okay, whatever we provided, okay, as a non-structural number which is exposed outside. So why they are focusing on the sunshade or kajas is that so it is a thin slab where the cover depth is not adequate enough as per the IS code. Okay, there is no minimum cover depth to be provided for the sunshades. So we will just protrude okay some reinforcement which is of 8 or 10 and then we will make the slabs, okay, protruded outside. So this and all, why this sunshade is provided means to prevent the entry of rainfall through the windows and also for protection against the sunlight. So since it is a very thin element, water will try to enter into the sunshade concrete and it will reach the reinforcement, okay, as the cover depth is very less. And also the railings what we are providing also are made up of thin elements. If it is in concrete structure, it will reach the reinforcement inside. And fins, so for some architecture point of view, here you can see the fins provided, okay, for an building. So this some projection pergola, okay, those things are thin elements where the cover depth is less so that it can reach the reinforcement and it will lead to corrosion. And third one is the terrace RCC. So if the terrace RCC, okay, is not because the terrace is the major element which covers our building from the rain and sunlight. So it will have a more exposure when compared to other structural elements. So if you're not making a proper protective coating onto the terrace slab means then there is a susceptibility of rainwater to enter and for the sunlight to have the thermal contraction and expansion, so that cracks may develop. Through the cracks the water will enter during rainy season and automatically corrosion will happen. So whether the terrace is properly insulated, waterproof, and also drainage. So drainage is also important thing. The slope what we are provided should be adequate enough to transfer the rainwater which is stagnating onto the terrace. If you are not providing proper slope, see mostly if the square feet, okay, is more than 600 means then we have to provide two, okay, drainage locations from the terrace. So if you provide a single drainage location for a larger area, then it will okay take some time to reach the outlet point, drainage point, thereby that also may lead to corrosion. So entry of water and thereby corrosion. And next fourth one is the wet area which is inside an unexposed wall. So normally if you are constructing an attached bathroom, or if the restrooms are located inside the building, then there is a susceptibility of the water to, okay, to be absorbed by these brick walls. And the brick wall, okay, is the most okay, effective material to transfer the water. Okay, and then the dampness will raise in the building, or okay, which finally results in the peeling of the plastic what we have given, and also the paint which has applied will try to, okay, peel off easily. And next one is the one side faced, okay, column or beam. So this is with respect to the column or beam which is exposed outside, okay, and to the environment. Suppose the column beam one side alone, okay, it will be exposed, and one side will be inside, the other two faces will be along the sides of the wall. So if it is exposed outside also, then the rainwater will try to, okay, have a contact with this surface of concrete, and also it will results in the entry of water and air. Okay, so only the concrete cover depth for the column is around 40 mm. And next, beams and column exposed to rain and sun for all sides. So this condition is practically not possible, but in some conditions, so if the beam column what they have constructed, whether they temporarily left out without making a ceiling and all, this condition will rise, where the beams and columns are okay, exposed to the environment in all the directions. So this those things also we have to give importance, mainly the dummy columns which we provided on the terrace. Okay, those things also will be exposed in all the three conditions. So dummy columns are the major important okay, element to be under maintenance, because so if a dummy column means, then the concrete strength will be of M10 or okay, less than M15, so that in future we can break that concrete and we can extend to the next floor. Suppose if the concrete strength is very low, M10, then it will try to absorb more water, since it is permeable nature, then automatically the entire column with the reinforcement will be corroded. So always we should protect the dummy columns, so with utmost care. And next one is the beams column slab located of the interior building. So the last preference, okay, almost given to the interior beam and column. So whenever a person comes and visit a building, means we should follow this order. Okay, mainly the outside terrace, okay, which has a wet, always the wet and water stagnating area. And second one is the thin structures. Okay, third one is the exposed, okay, water and terrace, and also the one side exposed outside of the column beam, and also inside the, okay, unexposed wall inside a room. Okay, so like that different conditions they have given. So we have to follow this order to do the visual inspection, and then we will come to an idea of what is the root cause for the, okay, damages in the building or the deterioration in the building. So the next important thing, okay, to be discussed is the assessment procedure. So far as we seen the order, okay, next we will see the assessment procedure. So what procedure we have to follow to evaluate a damaged building? So this is a flow chart which deals with the, first of all, the physical inspection, which we already discussed, and it also follows in standard order. Okay, so for that, if you have any doubt, we can take a material from that and we can do a testing for that, maybe a core cutting, okay, or a non-destructive testing can be done. And the second one is the study of document. This is very important. Whatever the document related to the building, the land documents, the other approvals, and the estimation and the design, if you are using a civil engineer for construction building, okay, you may give an okay, detailed estimate, okay, and also the plan of the building and the approval from the government officials, the land document, previously who is the owner of that land, whether it is meant or exclusively used for agriculture purpose. Okay, then you have purchased the land, like that all the details. Okay, you should, if there is a soil investigation carried out, soil exploration also, those things also we should have a look at it. So the document study is very important. And next one is the how much load acting to the building, whether it is G plus 1 or G plus 2, what is the actual load, okay, which is acting on the building, we have to See, and next one is the environmental effect, whether the building is located okay in a dry place or near a desert or in a continuous rainy season, or it is in an industrial area where continuous okay air pollution occurs. So those things under we should study. If a building is located in a heavily okay air polluted area means, then the okay CO2 and other chemicals will try to be deposited in the surface of the building, and when in raining it will try to enter into the concrete, thereby it will reduce the pH level and corrosion will try to initiate. Okay, mostly okay this condition will occur under a bridge. Okay, if there is a flyover is there, continuous movement of vehicle at the bottom ground floor, okay ground road will allow the carbon monoxide to deposit on the bottom surface or the soffit of the girder or the slab which is provided, and after some time it will try to enter into the concrete okay during a rainy season. So with these details we have to diagnose it. Okay, so you know about diagnosis, it is an important word okay from health point of a human being. Suppose if you have any problem like okay severe fever or continuous vomiting, okay if you approach a doctor to identify the problem, okay you will always okay give some lab test to be done. Okay, so that is called diagnosis lab. Okay, they can test the blood, the urine, okay, and the ECG and everything, and then they will identify okay what is the problem and what limits has exceeded in the blood level. Okay, so and what is the immunity in our body, everything they will diagnose it, and based on that the doctor will give the medicine. So like that, with all this detail we have to diagnose it. Once the diagnosis is over, we have to do a retrospective analysis. Retrospective analysis means we have to once again look back all the things whether whatever I diagnosed okay is matching with the details, with the visual inspection, with the documents, okay, and also the load acting and also the environment condition. With that we have to okay make an imaginary okay look back of the all the things, and we have to confirm okay whether the diagnosis what I made is correct or not. Once the diagnosis is confirmed, then we have to look for the structural adequacy. So presently this building how much load it can take. Okay, so whether the load is exceeded what it has applied to that, or it is very less, like that we have to predict the structural adequacy. So for that we can do a load test. Here you can see, so we can keep some barrel of water like a continuous UDL, or we can pile some sandbags. Okay, so like that, or we can do like a pile load test which with some reaction supports for plate load and pile load test. So like that in buildings also we can do. Based on that we can estimate the future of the building, okay, or what to be done, whether what are the corrective measures to be done, we can identify it. Okay, so with this I'll stop today's class. Thank you.